Alright, welcome back to another AP Computer Science test problem video. In this video, we're going to be talking about question 4a. So this question involves a path through a two-dimensional 2D array of integers where the path is based on the value of elements in the array. When an element of the 2D array is accessed, the first index is used to specify the row, and the second index is used to specify the column. Then they give us this location class that's used to represent a row and column position in the 2D array. So it's a pretty simplistic class. It just has these two ints, the row and the column, which represent the current row and the current column within the grid. There's a constructor where you just pass in the row and the column in that order to create a new location. So the actual problem that we're going to be solving is using this grid path class, but we're going to need to use the location class within part A. Then it says the following grid path class contains the 2D array and methods to use to determine the path through the array. You'll write two methods of the grid path class. So inside of this grid path, we have the internal state of a 2D array of ints called grid. So let's see what it wants us to implement for part A. So this one says write the getNextLoc method, which returns a location object that represents the smaller of two neighbors of the grid element at row and column according to the following rules. The two neighbors that are considered are the element below the given element and the element to the right of the given element if they exist. If both neighbors exist, the location of the neighbor with the smaller value is returned. Two neighbors will always have different values. If only one neighbor exists, the location of the existing neighbor is returned. And then it shows you an example grid and some example method calls. Then it says to complete the getNextLoc method. Okay, so let's sort of talk through what we want to implement here with some pseudocode first. It seems like there are going to be four distinct situations that we need to account for. So the first one is if we're at the last row and there's no neighbor below us. So if we are in the last row, then what does that mean? That means that we don't have a neighbor below us. We're in that last row, so we can't look one row below us. That doesn't exist. So that means that we're going to want to return the right neighbor. Okay, what's another scenario we might be in? We might be in the last column. If we are in the last column. So in this case, we don't have a neighbor to the right, so we're going to have to return the neighbor below us. That's another situation we have here. Okay, if, however, those two are not true, remember that it will not specify an element in the last row and column of the grid. So if we haven't returned in one of those two cases, it means that we're also not in the corner of the grid, and it means that we will have both a neighbor below and a neighbor to the right. The other two situations that we want to consider here are if the right neighbor is less than the below neighbor, or if the opposite is true. Remember, within the problem statement, it said that two neighbors will always have different values, so they're never going to be equal to each other. So we can say if the right neighbor value is less than the below neighbor value, then what? So remember, we want to return the location of the neighbor with a smaller value. So we will be returning the right neighbor in that case. And then if that isn't true, then what it means is that the below neighbor has to be smaller. So otherwise, the below neighbor is less than the right neighbor value. Below neighbor value. We're going to return the below neighbor. Those are pretty much our four situations that we're going to have for this getNextLocation method. So we can go ahead and start implementing some code. So one thing to point out is that within these four cases, we're going to be returning the right neighbor in two of the cases, okay, these two, and we're going to be returning the below neighbor in the other two cases. So remember that we're not just going to be returning the value of the right neighbor, but the actual location of the right neighbor or the below neighbor. So instead of creating them inside of these if statements, we can go ahead and just create them outside. So add create the below and right neighbor locations. because we want to be returning a location at the end of this method. So location is a object. So we say location, then we say the name. So let's say below neighbor equals, we use that new keyword, location, and then within the constructor of the location method, location class, we're going to pass in first the row and then the column. So remember that 2D arrays, we index the row first. So that first number we're using to move throughout the 2D array is our row. When we're considering the vertical position within our grid, that would be the row. And remember that the top left corner of a 2D array is at row 0, column 0. And as you move down the rows, you're going to keep incrementing them. So the row below that, it would be at row 1, below that would be at row 2. So if we wanted to create a location for the neighbor below, we would just add 1 to the row. The column would stay the same, however, because we're only modifying the row. If we also modify the column, we would no longer be a neighbor. Okay, so then when we create the right neighbor equals new location. So for this one, we actually keep the row the same, right? We're within that same vertical space, but now we want to move our horizontal space. We want to add 1 to our column. So now we're looking at the neighbor to the right. So now we need to figure out if we're in the last row. How might we do that? So probably going to want an if statement here. So how many rows are there inside of this grid? Int num rows. We can go ahead and save this into a variable. Well, that would be calling .length on grid. Right, that tells you how many rows there are. If we wanted to also save the number of columns, right, that's going to be, if you grab any of the arrays that exist within this 2D array, and then you grab the length of that, that will show you how many columns there are. So if we're in that last row, what does that mean? That means that the row parameter that's being passed in, if that is equal to the number of rows minus 1, right? Remember, because 2D arrays are 0 indexed, we don't want to check whether it's equal to the number of rows, otherwise that'll never be true. It has to be minus 1. So if we're in that last row, what does that mean? That means we don't have a neighbor below us. So we're going to return that right neighbor location that we created. So return right neighbor. All right. So that's that case. If we're in that last column, so what this means is if the parameter that's being passed in to get next location is equal to number of columns minus 1, columns is also 0 indexed, so we have to subtract 1 from the number of columns. Then we're going to return the below neighbor. In this case, there was no neighbor to the right because we were in the last column. So once we're done with these two situations, at this point we know that both the right neighbor and the below neighbor have to exist. Otherwise, we would have returned in one of these two cases. So now we can actually check the values within our grid. How would we do that? We want to get the value of the right neighbor. So we're going to be indexing this internal grid. So what row do we want to check? So if it's the right neighbor, we're looking in the same row that we currently are in. The only thing we're changing is we're looking at the column to the right. So if we add 1 to our column. If that right neighbor is less than the below neighbor, how do we grab the below neighbor? So now the row is actually going to change. We're going to add 1 to the row. We want to look below us, but the column will stay the same because we're within the same column. We're just looking 1 below us. So if that is true, if the right neighbor is less than the below neighbor, we're going to return the right neighbor. So return right neighbor. Otherwise, so in this case, this means that the below neighbor value is less than the right neighbor value, then this means that we're going to be returning the below neighbor. So return below neighbor. One thing that's super important to point out here is this method would not have worked if this code was above this case here, right? Why wouldn't it have worked? Well, at this point, we don't know if we're in the last row or the last column. So we might have been trying to index a row or column that doesn't exist, and we might have gotten an index out of bounds error. So make sure that you're doing these first two checks before you assume that there is a below neighbor and a right neighbor. All right, let's go ahead and test out our code now. So this first method call is 0, 0. And here is what our grid looks like. So we initially start off by creating these location objects so that we can return them later on. So I'm not actually sure how to represent this, but let's just say 1, 0 is the below neighbor. So that was, let's say, like row 1, column 0 is the below neighbor. And then the right neighbor is row 0, column 1. Okay, so we're going to be returning one of these two locations. Next, we're going to be setting number of rows. So that's equal to grid.length. So how many rows are there? There is 1, 2, 3, 4, 5. There's 5 rows. And then this grid has the same number of rows as columns. So it also has 5 columns. We can go ahead and check if we're in the last row. So the row that is being passed in was 0. And is 0 equal to number of rows minus 1? 0 does not equal 4. So we're not in that last row. So we're going to skip over this if statement. Then we check whether we're in the last column. So is 0 equal to number of columns minus 1? So is 0 equal to 4? It is not equal to 4. We skip over this if statement. Now we go ahead and we compare the values of the right neighbor and the left neighbor. So if we're currently looking at 0, 0, our right neighbor is going to be at grid of 0, 1, and that is going to be, that's the value is 3. And then we compare this to the below neighbor, which is at 1, 0, which is 11. So it looks like this is true. 3 is less than 11. So we are going to return the right neighbor in this situation, which is going to be that location object that we created with at row 0, column 1. And this matches up with the explanation for which value should be returned. All right, next method call is getNextLocation with 1, 3. So if we were creating these new locations, this one would be at row 2, column 3, and then this one would be at row 1, column 4. The grid length or the number of rows and the number of columns hasn't changed. Those are both still 5. So let's go ahead and check if we're in that last row. So does 1 equal number of rows minus 1? 1 does not equal 4, so we are not in the last row. So we skip over this if statement. We check if we're in that last column. So is 3 equal to number of rows minus 1? 3 does not equal 4, so we're not in the last column. So let's go ahead and check out this if statement here. Let's check if the right neighbor value is less than the below neighbor value. So we are going to be grabbing the value at 1, 1, 4, and that is equal to 16. And then we compare that to the value at 1 plus 1 is 2, column we're just passing in 3, and that is going to be equal to 15. So this is actually not true. 16 is not less than 15. So we're going to skip over this if statement and we're going to go into the else, and then we're going to return the below neighbor, which is at row 2, column 3. And this matches up with the expected return value for this call. Moving on to the next method call, this one calls it with row equal to 2 and column equal to 4. So when we create this below neighbor location, it's going to be at row 3, column 4, and then the right neighbor is going to be at row 2, and then the column is going to be at column 5. Number of rows is still 5, number of columns is still 5. We're going to go ahead and check if we're in the last row. So does 2 equal number of rows minus 1? So it does not equal 4. We skip over this if statement. We now check whether we're in the last column. So does 4 equal number of columns minus 1? So 4 does actually equal 4. So you might notice that we are in the last column. So we will be returning the below neighbor, which is the location at row 3 in column 4. And this matches up with the expected value for this method call. All right, last method call is with row equal to 4 and column equal to 3. So when we create our two location objects, the first one, the below neighbor, is going to be at row 5, and the column is going to be at 3. And then the right neighbor is going to be at row 4, and the column is going to be at 4 as well. So number of rows, number of columns still hasn't changed, the same grid, 5 and 5. So the first if statement, we check whether we're in the last row. So row, that parameter that's being passed in, does 4 equal number of rows minus 1? 4 does actually equal 4. So you'll notice we are in that last row. So we don't have a below neighbor, and we're going to be returning the right neighbor, which is the location at row 4, column 4. And this matches up with the expected return value for this method call. So here is the final getNextLocation method. We create the below neighbor and the right neighbor because we'll be returning one of those later on. We grab how many rows there are and how many columns there are in this grid. We check whether we're at the last row, in which case there is no below neighbor, returning the right neighbor if so. We check if we're in the last column, returning the below neighbor because there wouldn't be a right neighbor. Then we actually check whether the right neighbor is less than the below neighbor, returning that right neighbor if so. Otherwise, we know that the below neighbor will be less than the right neighbor and returning that below neighbor. Hopefully this helps you out with this problem. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.